Good afternoon, everyone. My name is Max. I'm a senior application engineer at BuildIT, and I'm going to be your host for this webinar. Before we get started, I just wanted to cover a couple of housekeeping points, and then we're going to jump right into the main presentation. So if you have any questions during the webinar, please submit it through the Q&A button, which is in the toolbar on the right, and we're going to try to answer your questions at the end. Secondly, the webinar is recorded and it might be made publicly available in the future. So let's avoid disclosing anything confidential in the Q&A. So for today's agenda, I wanted to cover first a little bit about BuildIT, to let you guys know a little bit about us. We're a division of Faro, where we're coming from, to give you kind of a background information for the automotive and how we apply our software in that industry. Secondly, there's the challenges of inline inspection. I'm going to cover three main areas: the hardware, how we can choose the right hardware to optimize for speed, for example; the data processing, which is the BuildIT software aspect of it. How do we process the data? And then finally, we're going to talk about automation, which is also, of course, a very important component of this. And then at the end, I'll spend a bit of time to answer your questions if you have any. So BuildIT is a division of Faro, but we've been acquired only a year ago. We've existed since in the early 90s, doing high precision dimensional manufacturing, quality control, assembly, and tool building. And we've traditionally worked a lot more with portable CMMs with probes, a little bit like what you see in the image on the left. So as you can imagine, with these many years of experience, we've built our software into a mature, stable software with a complete tool set of features and algorithms, and that means we have a versatile and comprehensive CAD importer. So any of the main CAD formats we can import. We have point cloud capabilities. As I mentioned, we come from a portable CMM background, and if you're a little bit aware of some of the softwares in the domain, there was a distinction where you could have these point-based software, so software that are more focused on the points themselves than features and all that. And we've kept this philosophy in the past few years, and this actually comes into play when it comes to the automotive and working directly with the point cloud. We also have the ability to fit. So this includes CAD to part fitting. So fitting a cloud to an existing CAD, or also fitting geometries onto a cloud as well. And then finally, real-time positioning, which is used a lot in assembly and tool building. And we're used daily on the shop floors around the world in leading manufacturing companies, 5 of the 10 largest aerospace manufacturers, 6 of the top 10 largest defense contractors. Okay, so to give you an example of how some users are using BuildIT in the automotive, BuildIT is used for tooling inspection or jig building. So things like, building that jig that the one that is holding the car in the picture, for example. You need to level the pads, provide real-time feedback on the measurements. We give a simple alignment command that allows you to do very complex alignments, and we keep it simple. And this is one of the biggest points of BuildIT, is the simplicity to do these types of workflows. There's also traceability. So as I mentioned, we keep the points in the software. Every point, we have information as to when that point was taken, what was the pressure and the temperature at that moment. And we have a spreadsheet, which a lot of our users like because it gives you all that information in a single view. And finally, we also have customized reporting. So yes, out of the box, the software has this template for a PDF report, which is really elegant, really nice, and good looking. But we also have an Excel type of report, which is ideal if you want to to work your data in another software, and we can customize that so that it's really seamless. So as I mentioned, there's ease of use is one of our biggest strengths, and BuildIT is also used for tracker surveying, which is it's an automated process, and we're going to get into the details of the things that we can do in automation. But when it comes to jig building, people are already using the automation for tracker surveying, which is basically taking a certain set of measurements at certain positions and cycling through those measurements at every time interval. So it can be, take those, these 10 points every 2 minutes, every 2 hours. It's up to you, and this process is able to just automatically cycle through all of these things at the time that you want. But now let's talk more about inline inspection. When it comes to inline inspection, there are essentially 3 components that we need to work with in order to obtain speed and configurability, which is quite important. The configurability aspect is taken care of by the automation. By keeping the automation simple and easy to manage, instead of giving you this black box that takes care of the inline inspection, you're going to be provided with an interface that makes it easy for you to understand what's going on and to make the changes that you want. So that's going to be actually the last part that we're going to cover. First, we'll talk about data capture, how we can achieve very high speeds, and then we're going to talk about data processing, which is the part that is mostly done by BuildIT. So starting with data capture, what's the right hardware for your process? The hardware that we're going to be mostly talking about right now is the imager. As I mentioned, we came from a portable CMM. Like in the past, we would use these hard probes, which would require very often a user to move it from position to position. And there's only so much you can do in terms of speeding that up. You can automate the whole process, but you're never going to get under, like something that would take, let's say, 30 minutes to do it manually. If you automate that, it could be maybe 5 minutes, maybe 3 minutes. We're not fast enough for inline inspection. So what you need is a soft probe or a scanner. And the imager, what it does is it takes everything in one shot. So really, we can really speed things up. It has a precision of 1 to 2 thou, so under 50 microns, a resolution of 9 megapixels, and it takes every scan takes under 10 seconds, depending on the number of exposure rates. You could even shorten that to maybe even 5 seconds. Really depends on your application, but now we're talking about a speed that's a lot more interesting when it comes to inline inspection. So with an imager, there's various setup options that we're going to cover. The first, starting from the slowest, the next to line inspection using a rotary table. And this one is neat because it's easy to set up. It's very easy to also copy and paste this solution. So we're going to cover that. Next, inline inspection using a robot. It's something that you probably have seen in the past. It's a fairly common way to go about things. And then finally, to achieve a really, really high speed, we're going to talk about the imager array, which instead of using a robot to move a single imager from position to position, what we're going to do is we're going to take all of the measurements simultaneously, or almost simultaneously. So first, next line inspection with rotary tables. You can see it in the image in the slide. If you wanted to see it in more, let's say in action, we have a video that's available online publicly. So if you look up scanning using Cobalt and rotary table, you should find it. But essentially, what you can see in the image is a simple setup. You have a Cobalt, and you have at the bottom this disk that will rotate. That's the rotary table. And what this allows you to do is really get a full 360 view of your part using a single imager. And it's really simple to calibrate. So this is already automated, the calibration. So essentially positioning the cobalt with respect to the disk is done automatically. It takes about a minute, and you don't have to do it again. And then the scanning part of it takes another minute. So it's really as long as it's a 2-minute video. You're going to see it in pretty much in real time how that works. And we consider it to be next in line inspection because of the time that it takes. Right? If a scan takes, let's say, as we mentioned earlier, 10 seconds, and you want to rotate that table 5 times to have 6 different positions, um, it's going to take you a minute to do the full scan. But because of that, it becomes more of a next to line inspection where you would think you would expect somebody to take the part off the line, put it on the rotary table, and then after it's done scanning, you put it back on the line, and then you take the next object. It's simply, due to the setup and due to the time of inspection that it would be next to line. But what's good about this is that you can take this very same setup and basically copy paste it everywhere. It's not, it takes almost no configuration in order for this to work for your setup. And since the scanning is a little bit slower, maybe you would use that in conjunction with SPC to really leverage that statistics side of it. And so BuildIT has a way to output that data for your SPC software of choice. But now let's look at something that's a little bit more versatile, although it takes a little bit more work to implement it, and that's inline inspection with robots. Unlike the rotary table, which has 1 degree of freedom, this one has 6. And so that means it could position the scanner anywhere, including inside of the structure. So it's really flexible in terms of where you can scan, but the robot movements need to be programmed. It has to be planned. But once that part is done, you have BuildIT that takes care of moving the robot to the right position, and then telling the scanner to take the scans, and it'll take care of programming these things at the fastest rate that it possibly can. But it is limited, right? You still do need to move from position to position, just like the rotary table. So what if you want it to go even faster? Well, the solution for that is the imager arrays. So the way that this works is that you can connect multiple arrays, multiple imagers, together, so that you can synchronize them to take the measurements at the same time. And this is a unique feature of this device because it comes from the fact that the connection is an Ethernet connection, and that allows a many-to-many connection. So you can have multiple cobalts connected to, it could be a single computer that controls it, or also you can have multiple computers taking care of the processing. So one after the other, they'll obtain the measurements from the array and then process that. So what this allows you to do is really crunch that time to something that's extremely fast. So as I mentioned, we saw in the previous examples, you might have 6 positions. 6 positions times 10, we're at a minute long, right? If you do this simultaneously, it'll only take 10 seconds. The only thing about these devices, the way that they work is that they emit this light pattern on your part. And it's important that when they scan, they don't have an interference where both patterns are overlaying like this. And so in those cases, what you can do is have 2 sets of cobalts that takes the scan one after the other. So it can take at most 20 seconds to go through your measurements. And then when it comes to the cloud processing part, BuildIT is phenomenally fast. We're talking, again, it depends on the part and how much analysis you need to be done, but it will take a ballpark of 10 seconds. So the whole thing can be kept within 30 seconds, but the scanning part itself is just 10 seconds. So this is really really neat. If you need to go to the top speeds, this is the way to go. So we talked about data capture. We're going to get to data processing. Just before we move on, I just want to remind you, if you have any questions, uh, please press the Q&A button. I'm just going to have a look at whether we have any questions that came in. Doesn't look like it. So anyways, I encourage it. Please don't hesitate. So let's go to the next slide. Data processing. Okay, so can everything be analyzed, and can it be analyzed quickly? We're going to talk about a couple of points in BuildIT. Cloud processing. We're going to specifically focus on how we can achieve high speeds. Part of the way that we do that is by bypassing the whole meshing part of it, which we can do quickly, but it does add a delay, and we can bypass that completely. Secondly, there's flush and gap, which is a measurement, a type of measurement that's very specific to automotive. It could be used elsewhere, but mostly in automotive. And then finally, we're going to talk about GD&T analyses, what BuildIT can do, and how it can process clouds for these kinds of analyses. So first, point clouds. We're able to handle huge point clouds. The size of it is not an issue. Sizes that would probably slow down other software are not a problem in BuildIT. As I mentioned, as a point-based software, this is a very important point. Secondly, no meshing needed. You could turn this into a mesh, but instead, what we prefer to do is to process these points directly, and there are two main aspects to it. The first is outlier removal. So we have a very efficient way to remove outliers using the points themselves. And also we have a way to control density. So to reduce the point cloud so that when you have these overlaps, you don't have this excessive data that's only going to slow down the process rather than providing additional info. And so with a combination of outlier removal and controlled density, you have a much more a much faster process. Just to move to the next slide, we have flush and gap. Flush and gap is new in BuildIT 2017.5, which is just about to be released. And the way that it works in BuildIT is that it works on a full scan cloud. There's no CAD required. And this is important because in automotive, if you're going to use imagers, the scan comes in one shot. It's not like a gap gun, for example, that will give you the flush and gap in real time. And as nice as it might be, the reality is that the imager gives you all of that data in one go, and you need to provide the flush and gap, just like in the screenshot here taken from BuildIT. And if you want to see how that works, what the command looks like, we have a video online. I don't want to waste your time too much on that. But for those who are not familiar with flush and gap, I have a slide here just to explain to you just a little bit what it is. Flush is that step between two surfaces. So imagine a car door, right? As you run your hand on it, you shouldn't feel like a sudden jump when you're crossing the gap. It should feel like a single surface that just has that slot in the middle. So that's that flush, and then the gap is the width of the gap. And this is more of an aesthetic thing where when you look at a door, you want that gap to be nice and even all around. Otherwise, it just looks like lower quality. So this type of inspection can be done with an imager in BuildIT because we can actually extract that information from the cloud. Next, we have a GD&T analysis. We have a comprehensive list of tolerances. The features include slots and plenty of other more complex features. that you can align to or inspect. And then finally, we have multiple alignments that can be calculated in the background, but that can also be recalled, which is quite nice if you want to see exactly what's going on in your model. So I have a specific example of this. Um, the imager array that you saw earlier was shown at the control show just a couple months ago, and I just want to show you guys the model itself. All right, so this was taken by um, an array of 6 cobalts for this car door, and what I can do is what we see is we actually we see everything. I'm going to remove the measurements just for now. Okay, so this is an example where um, the part is made of sheet metal, and this poses a particular challenge when it comes to hole positioning. When you want to inspect the position of a hole, it becomes very difficult for a scanner to obtain all of the necessary points on that very thin cylinder or that thin slot right here. So instead of using the points themselves as a description of where the hole is, we can use the absence of points. So a hole in the cloud tells you where the hole in on the physical part is. So let me bring back the cloud in here. And what I'm also going to do is I'm going to turn it into a wireframe mode just so that we can see just the cloud. Okay, so what we needed to do instead of using the clouds themselves is to extract the edges. And this was done by our edge extraction command. So edge detection. This allows you to pick out those points that I've highlighted in red right here. And this is what's used for the various GD&T. So let me just show you a little bit of some of the views. So that's the initial one. I believe we can look at datum C. So by recalling that view, I brought the annotations and I can see the different tolerances that are on these holes. So we have a circle feature, has a tolerance for the radius, position, and so on. And this is all thanks to the edge detection. So as I mentioned, the list of tolerances, you know, we cover all of them. We have a lot of features. We have complex surface features as well. But I'm not going to spend too much time on that. This is really, we're going to be getting outside of the scope of this webinar. But yeah, so that's something that we can do. Just bringing back the presentation. So that was the data processing part. And now we're going to get to the last part of the presentation, which is the flexible automation. And again, for Q&A, checking real quick, just use the button on the right. Okay, so flexible automation. Automation is really a big strength of BuildIT. As I mentioned, BuildIT has over the years, it has accumulated a big tool set of commands. And despite the large set of commands and all the things that you can do in the software, we went ahead and we automated everything. So for anybody who's familiar with BuildIT, how to use it for pretty much any workflow can be automated. There's nothing that's out of bounds. But we can go further than just staying inside of the box of what BuildIT does. We can go even further, and we're gonna touch on that in just a second. But one of the things that people like about BuildIT is that we provide a dedicated user interface. And I'm going to show you guys that interface that you can see. I think I have an example right here. So we have a process here that I just ran. Those are example processes that, by the way, if you download the software, you have access to this. You can run it for yourself and see it. So I ran the demo part inspection where you can enter your name. It looks like a command, but it's actually a process. Serial number, and then you can click apply. And it'll run through the process, give you the instructions, and so on and so forth. Now, at this point, you can see on the right, there's the list of steps that it's going to walk you through. And this is what this is the interface that I'm talking about. Instead of having everything in this obscure cryptic code of a process, instead what we give are specific steps, and these steps have parameters. So for example, these setup instructions, I might want to display an image, right? And this step has the parameters on the right. They're easy to change. I can browse for an image, for example. I can drag this elsewhere. We have the ability to have loops and variables. So what's an example? So in here, what we can do is we can have conditions. So if something exists, or we can ask the user, um, and so on and so forth. We can loop things over and over again. And so by keeping this kind of interface, it makes it easy for a user and later on to change things up, to apply it to a different part. Now coming back to the bullets right here, the third one that I want to cover was in terms of dedicated user interface, was the searches. So we also have the ability to search for objects that have the same properties, and that allows you to have a process that you can use on multiple CAD independent, like. And what's nice about this is you can copy paste it. Essentially, you can just reuse it over and over again, because you're searching for the surfaces instead of having a specific name or a specific CAD that it works with. And then finally, we have advanced calculations. So not just addition and subtraction, but what we can have trigonometry, exponentials, all of the things that you find on a scientific calculator. Essentially, you can do these calculations in there. So really, we've broadened the number of things that you can do with automation. Also, the processes work like functions. This is another specialty or a specific feature of ours, which is that you can take a process and you can call the same process by with another process. So it works like a function. So for example, if I created a process that will, let's say, cycle through the different views, a little bit like what you see in our public videos. Actually, we'll show you the different views of the part, and this is purely for aesthetic reasons for the video, but you might want to do that for whatever reason. Well, what we can do is we can have a process that will search through all of the views that are available in the CAD, and now you have this process that you can just use for any other part that has a list of views. So this is something that uh, makes the whole thing just a lot more easy to manage. If I were to upgrade or improve that function that cycles through the views, um, that improvement just is available for all the commands that call the same function. And then finally, we interface with scripts and machines, or even other programs. So instead of being confined to things that are just purely um, things that everybody might want to do. So if you have a more of a niche um, application, then if it's quite complex, you might need to have a script, or you might have your own machine, whatever it is that you want to interface with. Essentially, we can connect it to the automation. So a great example of this is actually tube bending. We have a client that inspects their exhausts with BuildIT, and it's not as simple as doing a CAD to part inspection. It's not just comparing the points to the surfaces. In fact, it's a lot more sequential, and it's pretty niche as well. So instead of having a dedicated software that's that's just not BuildIT, what we did is we created a process. So somebody who's already familiar with BuildIT doesn't need to go elsewhere, just runs the process, and it goes through the steps of first extracting the cylinders from the point cloud, uh, and then getting the axes of these cylinders. And then you need to intersect these axes, and these intersection points are what you use to calculate the LRA, which stands for length, radius, angle, which is a specific way to describe a tube. And you need to do that both for the nominal. So you might import the CAD, but you don't have the LRA. So you need a process that takes care of that. and the actual, the scan itself. And then you can do the comparison between the two. So this one, we have a video available online. You can look that up for automated analysis of a scan tube. But this is just a great example of something that just uses the flexibility of our automation. So we've covered the three elements of how you can have a fast but configurable inline inspection workflow. But we have a team of integrators at Faro. So if you need a turnkey solution, what you can do is you can discuss with anybody from sales at BuildIT, and we can talk about what's right for you, what would be the good configuration, or just lead you in the right direction. So if you have any questions, don't hesitate to ask sales at builditsoftware.com. You can also give us a call, whichever one is you prefer. So that's it. We're now at the Q&A session. I'm going to look at if we have any questions. Let's see. And it does take, there's a delay between when I do the presentation and when you actually receive it. It takes about 20 seconds. So it might take a little bit of time for the questions to come in, but it looks like we have a couple. Okay, so once an automation has been written for a given part, how easy is it to reuse it or adapt it for other similar parts? It's quite simple. It's just a question of using some of the more advanced functionalities. So, for example, creating an automation in the first place is quite simple. It works like a macro. So you simply need to hit the record button and walk through the steps, and it'll record everything, and then you have your process. So this process is already ready to run on that single part. It was just a question of recording it. Now, if you want something that can be adapted for other similar parts or similar devices, a lot of things can change. Well, then it's just a question of changing it to using the search function that I mentioned earlier. You can have a search function so that it'll just use all surfaces of the CAD instead of a specific set of surfaces. These kinds of things. The other question: where to download demo software? Can you share the presentation? Right. Yes. So you can download the demo software on www.builditsoftware.com, and you can just go to I believe it's the support menu, and then it's downloads. So you can download the software right there. It's free. You can get a free trial, no problem. So just fill in the form, and yeah, you'll have access to it. And as I mentioned, you have access to the processes, but just to bring back the software, there's not just the processes that you can look over here, but we also provide example models. So if you want to see them, see the different types of analyses or GD&T or models that we work with, they're easily accessible in this menu right here. And can I share the presentation? Yes. We're going to follow up. You'll have probably an email automatically, I believe, and it should contain the presentation. Are there any other questions? I guess we're going to, I guess, end on this note. Well, thank you guys for your attention, and hope to see you at the next webinar. Thank you.